Assalamualaikum. My name is Amir Hazib Hazar Rizal from Group 1. Today I would like to present for our topic, which is replacing the material in concrete. So, for our topic is the use of seashells in concrete. So, for the introduction, as you can see, concrete is one of the two most used structure materials in construction. Every year, the use of concrete increasing 2 ton for each people. So, in order to reduce reliance on raw material in concrete producing, the green concrete has been promoted. So, the green concrete is the concrete that has been produced using recycled or waste natural materials. One of the ways to produce green concrete is by using modified cement. So, modified cement is the second largest volume material used by human being after water. So, cement plays the role of a binder, which is a substance that sets and hardens and might bind alternative materials along. During production of cement and hydration process of cement, the amount of carbon dioxide emitted by the industry is nearly 900 kg of carbon dioxide for every 1000 kg of cement produced. So, this carbon dioxide production causes serious environmental damage. Seashells have a high potential for the use of partial cement replacement and concrete filler. So, the calcium carbonate content of the seashell is around 90%, which is comparable to the calcium carbonate content of limestone dust used in Portland cement manufacturing. So, seashell crystals formation are mostly made up of calcite and aragonite, both of which have higher strength and densities than limestone powder, which is the original one. So, furthermore, the particle size of the seashell ranges from 36 to 75 microns, which is comparable to particle size of Portland cement.
My name is Muhammad Nur Azri bin Muhammad Ahir. My metric number is DF180159. So, I will present about the literature review. So, seashell are the species that can be found in the beach, seacoast or other area that has salt water. So, the seashell is recognized as the waste because the presence of it has caused the decrease in the marine current, increased the sedimentation of particles on the seabed, and will cause a decrease in the DO concentration which near the cultivation area. So, this is the most of the waste seashell. It consists of the oyster shell, periwinkle shell, scallop shell, mussel shell, and cockle shell. So, most developed country will dump its seashell waste in the landfill or the sea. If we see on the Australia, the disposal of the seashell waste can cost to $150 per ton. And if we look to the China, which is currently the largest producer of seashell, they have recorded around 10 million ton of seashell waste which has been disposed in the landfill annually. It consists of the oyster, scallop, and mussel shell. These seashell waste mostly will be dumped at the landfill, and only small percentage that will be used back as fertilizer and handicraft. So, the bigger problem for this country is it can be seen as illegal dumping, which is illegal dumping of this waste into the public water and reclaimed land, which can cause the bad odor which result from the seashell waste that has been decayed. So, this is the seashell chemical composition. The chemical property of the seashell is generally composed of the calcium carbonate. Oyster shell microstructure can be separated into two parts, which is a sheet face layer and porous lash layer. The function of the sheet face layer is to enable the growth direction of the seashell. The porous lash layer is a layer between the sheet face layer. So, as it can be seen in this table, this is the detail of the chemical composition of the seashell. As it can be seen, the major chemical in the seashell is the calcium carbonate and silicon dioxide. So, this presence of the silica in this material has suggested that it is the pozzolanic material, which are suitable material for the cementitious material for the concrete.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm here today to presenting the methodology of our project. So, in the figure shows the test program, which shows the different types of concrete and tests that will be performed. The test program is based on a common mix design that allows for paired comparison testing between the shell modified concrete and the plain concrete and plain control sample, with shell replacement rates as high as 20% to extend early work and analysis the final effects. This study used a significantly greater aggregate substitution of 50%. The replacement for sand and coarse aggregate were selected to represent a minimum and maximum dosage. When early work was analyzed, the lower 10% addition was believed to be at a very conservative level, and the 50% level was picked to reflect the highest increase that might yield a commercially usable concrete. The strength and permeability of concrete constructed using seashells were evaluated using a compressive strength test and porosity test. Compressive strength is a widely used criterion for determining the quality of concrete. The porosimeter test involves applying water to the surface of hardened concrete at a pressure of 5 bar in order to determine the depth of penetration and hence the permeability properties of the concrete. Okay, so we move to the result. In this figure, it shows that using seashells as a partial aggregate replacement reduced porosity by 70% for a 10% coarse aggregate replacement, 6% for a 50% coarse aggregate replacement, 20% for a 10% sand replacement, and 36% for a 50% sand replacement when compared to plain concrete samples. The porosity of the concrete type used had the following standard deviation values, which is plain 7.58. In sum, 10% replacement aggregate was 5.75, 10% sand replacement was 0.66, 0.67, 50% sand replacement was 1.58, and 50% aggregate replacement was 1.36. The standard deviation for plain concrete was 7.58, while the standard deviation for 50% aggregate replacement was 1.36. A modest discrepancy in water penetration between these two concrete samples is partly explained by the scatter in the data. The shell size and amount were the only physical difference between the 50% aggregate replacement and the other concrete types. This could have had a significant impact on the permeability results. The scatter across the different concrete types would be smoothed out with a bigger sample group. The use of seashells in concrete has a clear tendency toward lesser porosity, which could be related to the chemical composition of the seashells, creating a less porous material. Furthermore, when placed in the suitable plane against the flow of water, the flat layered shell aggregate can be compared as a water barrier, and 10% aggregate replacement has no effect on compressive strength, and the mean compressive strength value for the plain and 10% replacement concrete type was 36.24 Newton millimeter per second. Newton per millimeter square, with a standard deviation of 1.06. The findings are consistent with who found no discernible variation in compressive strength for shell additions ranging from 5% to 15% of aggregate replacement. The compressive strength was lowered by 17 and 29% respectively when the shell content was increased to 50% of the aggregate and sand replacement. 20% fine aggregate replacement and reported lower compressive strength found similar results.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Musab Saleh Al-Tijama, metric number EF200187, and I'm taking over this part. Concrete is used for many applications, including basic foundations, superstructures, wastewater treatment facilities, water treatment facilities, parking structures, floor construction, and exterior services. Along with concrete, the form system has evolved to allow for more efficient placement, large quantity placement, and artificial architectural finish features that may be desired. When referring to quality associated with concrete work, it may include that the finished appearance, consideration, or accuracy of the placement. While all of these are important, the qualities goes much deeper. Concrete qualities begins at the project conception while specifying appropriate strength required to support the structure. Concrete mix design, ingredient, desired finishes, and need to specify work that is constructed. When constructing with concrete, it is vital to properly understand the reinforcing requirements, accessory requirements, desired and unachievable strengths. Historical data relative to materials being used, proper replacement of materials, and tracking of periodic trending strength to ensure design parameters are being met. In addition to strength tolerance for concrete is critical. Consideration of concrete and reinforcement coverage is paramount to avoid removal.
Hello, hi. My name is Muhammad Nakir Shabi Abu Bakar. My metric number is CF190062. So we go to part conclusion. Seashell is the best material as a material replacement in concrete. This is due to the fact that using seashells in concrete aids in the management of seaweed waste as well as the production of cost-effective concrete. The use of seashell waste ash as a partial replacement for cement in sustainable concrete has been validated by the literature assessment. The study found that adding seashell as ash to concrete lowered its early compressive strength. The strength raised with age owing to calcium oxide hydration, although it was still lower than control samples. The establishment of excellent bonding between the binder matrix and aggregates enhance the flexural and splitting tensile strength, which raised the modulus of elasticity. However, other investigations have found that splitting tensile strength has decreased.